So welcome to this. This is the FMSP online revision session for AQA Statistics 2. And in this session we're going to be building on DRVs by looking at continuous random variables. So we need to make sure we understand what's different, because then we need to choose the correct formulae. We need to be able to work with PDFs and CDFs. We need to be able to find medians, quartiles, percentiles, means, variances and standard deviations. As with DRVs, we need to be able to find means and variances of simple functions, and also we need to be able to use the rectangular distribution. So you're given a fair chunk of information, and you can see a lot of this is very, very similar to a discrete random variable, except we're replacing a summation with an integration, because fundamentally they're the same thing. Okay, we're given the relationship that the cumulative distribution function is the cumulative probabilities, which is what you do with binomial and Poisson, and it's equal to an integration. So, during 2011, we're given a continuous random variable as defined here. That's the PDF, little f of x, and we're told, whoops, let me just finish those off, that it's equal to three things. Either, if you're between 0 and 1, it's going to equal 3/8 x squared plus 1. If it's between 1 and 2, it's going to equal a quarter, 5 minus 2x, and it's going to equal 0 in other situations. Okay, so we've got to show that for 0 to 1, f of x is this. Now, personally speaking, I prefer to not use limits. So I would be integrating this 3/8 x squared plus 1 dx, and if I integrate this, it's going to give me 3/8 of x cubed on 3 plus x plus a constant. Okay, so that's going to give me x cubed on 8 plus 3x on 8 plus c. I'm then using the fact that if I put 0 into this, I should get 0 because that is the bottom of my stance. Okay, there's no cumulative probability, so that 0 there comes from here. So I know that if that's big f of x. So I know that if I put 0 into this, so f of 0 must equal 0, which is 0 cubed on 8 plus 3 lots of 0 on 8 plus c. So that tells me that c must be 0. Therefore, f of x must be 1/8 x cubed plus 3/8 x, which we can then factorise x on 8 x squared plus 3. So you get 3 marks for this. You get 1 mark for doing some form of integration. You then get an accuracy mark here for doing the integration correctly, and showing that c is equal to 0 will give you the final accuracy mark. So we kind of do need to do that bit. We can't just ignore it. We're then asked to verify. Please be very conscious about the word verify. Okay, verify that the median is 1. So in other words, what does that mean? Well, the median has this definition. Okay, 50% of the data must be below it. So what is f of 1? Well, f of 1 is 1/8 of 1 times 1 squared plus 3, which is 4/8. Therefore, m is equal to 1. So that's what we mean by verify. Okay, so we get a B mark for using this statement and a B mark for then actually showing that it's true. We're asked to show that the upper quartile. Now I know that the median is 1, so therefore I know that the upper quartile must be bigger than 1, which tells me I must be in this region here. Okay, that's very important, you know where you're dealing with. Okay, so what is the definition? Well, I know that f of q must equal 0.75. Okay, so what's that? Well, that's a quarter, 5 minus 2x. Well, now there's the issue, you see, because this is little f of x. So actually, this is why it's worth 5 marks. We need to find big f of x. So here we go. Now I know that f of 1 is 0.5. That's going to be really helpful. So let's go. So I know that big f of x for this particular region is the integral of a quarter 5 minus 2x. So if I integrate this, it's going to give me a quarter of 5x minus x squared plus a constant. Okay, now what do I know? I know that f of 1 must be a half, and that must equal 5 over 4 minus 1 over 4 plus k. So that tells me that my k can be evaluated. Okay. So what is k? 4/4. K is a half. So therefore my f of x is equal to a quarter of 5x minus x squared plus negative a half. Okay, so now I can solve the equation. So 3/4 is equal to, well, I'm going to write this as 5x on 4 minus x squared on 4 minus 2 on 4, because I can. And if I simplify this going on, so the 4's cancel, and we can see quite clearly that x should be q, but I can now see very, very clearly that that's going to give me the q squared minus 5q plus 5 equals 0 that is required. And then we solve this. Now, it's given in the exact form, so completing the square is probably the best. So q minus 5 on 2 squared minus 25 on 4 plus 20 on 4 equals 0. So q minus 5 on 2 is equal to plus and minus root 5 on 2. We don't take the negative because that will give you something that's not between the range. Okay, so you get a lot of marks for this, actually, 5 marks. So you get a method 1 for doing an integration, an accuracy 1 for getting to the equation. Okay, you then get a method 1 for trying to solve the quadratic, you get a little method 1 for ignoring the negative 1, and an A1, for ignoring the positive 1, so you need to check both of them, and then A1 for the final answer. We're then asked to calculate the exact value of the probability. So to do this, what we do is we can integrate from q, okay, to 1.5 a quarter 5 minus 2x. Okay, that's the easiest way of doing this. So that's going to give me 5x minus x squared evaluated between q and 1.5. I'm going to leave it in terms of q for the minute. So that's 5 times by 1.5 minus 1.5 squared. Now, I know something. I know that q squared minus 5q is equal to minus 5. So, in fact, actually I'm going to have minus the minus 5. Oh, I forgot my quarter, sorry. Okay, and we should have a quarter here as well. So if we calculate all that through, that's going to give me a quarter minus 3/16, which equals 1/16. Okay, so that's a quick way of doing that. So M1 for setting out the integration, A1 for getting the correct values, okay, B1 for working this through, and then an A1 for working out the final one. Now this is slightly different than the mark scheme, but I think this is slightly more efficient. Okay, so June 2010 question 3. We've got a continuous random variable. Now it's got a rectangular distribution, and it's asking you to sketch. Now if it didn't, you should do this anyway. Okay, so what do we have? Well, we're going from k to minus 3k, and it's got a value of k throughout. So your distribution should look something like this. And we've got to show that k is a half. Well, what do I know? I know that the area is 1. So I know that 4k times by k must equal 1. So k squared is a quarter, so k must equal a half. Okay, so you get 2 marks, 1 for getting the width correct, 1 for getting the height correct. You then get 1 mark for recognising that the area must be 1, and an accuracy mark for them working it through. We're then asked to work out exact numerical values of the mean and standard deviation. So we're told stuff. On our formula sheet, we're told the following 2 pieces of information. Okay, so the expected value is going to be a plus b over 2. So that's going to be a half of a plus b over 2. There we go. So that's going to give me minus k, which I now know is minus a half because k is a half. So you get 1 mark for that, B1. Then for the variance, it's going to be 1/12 of b minus a squared. So that's the variance. So if we work that out, that's going to be 4k squared. So that's 2k on 12, which is k on 6. Okay, but of course I want the standard deviation. So that's the square root of that. So the standard deviation, k is a half, so that's a 12th. So it's 1 over the root of 12. Okay, sorry, 16, not 2. That's 4k. So 2/3 k. So let's change that. Okay, so k, so that's going to give me a third. So it's the square root of a third, 1 over root 3. I prefer you don't leave it like that, but you can. Okay, so you get 2 marks for that. You get a method mark for using the formulae and an accuracy mark for getting the correct answer at the end. And then part C, we're asked to work out the probability of x being greater than or equal to a quarter. So again, it's easiest to do this through a sketch. So that's a half, and we're going down to minus 3 over 2, and it's a half high. And I want the probability of being greater than minus a quarter. So the easiest way in my head of doing this is to realise that that's going to be a rectangle where we've got an area of 3/4, a width of 3/4, and a height of a half. Okay, which is going to give me 3/8. So that's M1A1 for recognising that. And then writing down the value that x is not equal to a minus a quarter. Well, what I do know is x equals negative a quarter is 0 because it's continuous. So therefore, the probability that it doesn't equal minus a quarter, therefore, must be equal to 1. And you get a B mark for that.